maybe first going back to the presentation or a slide actually that I showed you yesterday when we were starting. This is the slide I warned you that you do not have a copy of. As I said, it's just a list of topics for me to remember what are we supposed to do. And I thought it would be a good idea to see how far did we get, what have we covered yesterday. I believe that the information I gave you yesterday covers the 5G network architecture on the overall level, and we looked into the 5G network functions, basically just describing what are they for. I will talk much more about that in the days that we have until Friday, because I will kind of activate each of these in the relevant moments in time. So we will actually gather much more information about compared to what we did yesterday. We have also just introduced as much of the NFV as I felt is necessary for us. We will return to this solution because virtualization, when we start talking about network slicing, which we didn't do really yet, network function virtualization is a very good tool to give network slicing to. And the software-defined networking, we will be back on that also. I have also been waving my hands a little bit about 5G registration and PDU session setup, so I hope by now we actually know kind of what this is and what is it for. The 5G registration is the UE saying, hello, I'm here, and the PDU session setup is an agreement that is reached between the end user equipment and the transport network as to what kind of resources should be granted for the session for that are inside that session, because a PDU session is just a connection to an application server on the user plane, while then this user plane we will need to define certain resources, and if it so happens that the PDU session has a number of different data streams with different quality of service or different routing needs, then within this PDU session we will have a number of so-called quality of service flows. So this part over here we will talk about in the coming time, but I'm we've more or less covered this part over here. And as I said yesterday, before we move to any new foldout and start digging into the relevant details, I would like to start with this 5G registration and PDU session setup based on what we said yesterday. And in order to do that, well, this is communication between the UE and the certain elements, network functions in the control plane, the ones that are on the service-based architecture. But it is also the user plane itself involves the G-Node B, involves the UPF that have to be ordered what to do. The G-Node B is told what to do by the AMF, Access and Mobility Management function, controls the radio network, while the session management function controls the user plane function. So I would like to talk a little bit about this communication, and if I want to talk about communication, I would like to start with a slide in which we can see the language, or to be more precise, languages that are used for the communication. We mentioned HTTP yesterday as the standard protocol that is going to be used between all the network functions in the 5G core network. But as I pointed out, when we talk about communication from the core to the radio access network, and when we talk about carrying the user plane data, it's not HTTP down there. So I would like to ask you, in this pile of slides that you have received, to go to slide, we are in chapter number 2 at the moment, to go to slide number 18. And in this slide 18, as usual, the first thing is, do we understand the title? protocol stack. Protocol stack is the set of protocols. Down here is the physical layer, and then up here we have the application layer. All of these, each of them is responsible for a certain functionality in terms of communication between the different endpoints. And in this particular slide, the protocol stacks that we see, this is for the 5G solution. You see the AMF, SMF here, so the 5G core, and we have the NG RAM. Because please remember, as we said yesterday, that what we see here, which is the standalone option of 5G, is not the only way of deploying so-called 5G in the live networks. In the case of non-standalone, I should have here a protocol stack between the UE and the G node B, but then past that we should have the 4G core network. So you don't see all of the protocol stack options here, just the standalone situation. Now, another thing, as we said yesterday, red color means signaling, so that's the control plane. Green color, the bottom half of the slide, this is the user plane. And if we start with the control plane first, two abbreviations that are very useful in the signaling context. Non-access stratum. This is the abbreviation is from the perspective of a UE, of the user equipment, and from a UE perspective, non-access means the core network. So non-access stratum is how can the UE communicate with the core network, which means I need a common language between the UE and the access and mobility management function, because this is the only core network function that the UE is allowed to speak to. This is what we'll use during registration. And you can see over here it says non-access stratum mobility management, which by the way in the 3GPP standards is called 5G mobility management. So you can see this abbreviation sometimes. And then when you want to establish a PDU session, well, on one hand, if you want to start a user plane connection, the UE needs to speak to the session management function. But as we said, we do not have a direct interface interconnecting these two. So the UE will build a session management function, send it through the G node B, through the AMF, and then from the AMF to the session management function. So these are the endpoints of this particular application layer protocol, the UE and the session management function. This protocol, 5G session management, if you look at this abbreviation, it's actually a little bit funny, because if you read it normally, I would read it 5GSM, so 2G pops up here, but this means 5G session management. So this is the non-access stratum communication towards the core network. And please notice that when the UE wants to talk about a session to the session management function between the AMF and the SMF, this is the N11 interface. We saw the reference point architecture slides yesterday towards the end of our meeting. Here we are using this HTTP/2. So what happens is the original session management message gets packaged and it will be put as a payload into the HTTP to carry it. And this is what we are using, for example, JSON for. Now, apart from that, the UE speaks radio resource control to the G node B, and this is a dedicated application layer protocol on the control plane, where the G node B and the UE agree on what radio bearers should be used. Maybe you remember from yesterday's signaling radio bearer is established to perform signaling, and data radio bearer to carry the data. Now, if we need to carry whatever the UE says, either about the radio or simply the non-access stratum, between the G node B into the core network, into the AMF, the protocol over here is called MGAP, Next Generation Application Part. And below these protocols that are marked in red here, which means they are application layer, we have the service protocols. Packet data control protocol, radio link control protocol, media access control, and the physical layer. And the same goes here when we look at the interface that connects the radio with the core network, stream control transmission protocol sitting on IP, and here HTTP sits on the TCP and on the IP protocol stack. These protocols are in white. They are service protocols. They are from the lower part. They are more connected to handling the physical layer, the security, the multiplexing, things like that, for the messages that are actually supposed to be carried. So for me, these are simply languages that can be used in the relevant points to talk with each other. We have agreed that we are using English. If I move over to Polish, there will be no communication, and if you start saying in Hungarian anything other than Egészségedre, I will be lost. So this was what I mentioned, that when a UE is supposed to be a 5G UE, it has to have the software, the non-access stratum, signaling into the 5G core in order to be able to talk to it. In the standalone option, in the non-standalone option, it would be the 4G NAS, which is slightly different but fulfills the same functionalities. Now, if I move down to the lower part of the slide, meaning the user plane, you can see over here that a UE will build the information that it wants to send out, the actual data, will be built into a protocol data unit. And you can see where the protocol data unit is supposed to go to. This is a data network node, an application function, an application server. This is whom we ultimately want to talk to. And this endpoint, as we said yesterday, is reachable through this external interface. That's the N6 interface. But this PDU is also visible to all the, remember that we can chain user plane functions. We can have a number of them on the path of the data. Each of these user plane functions will do routing based on some routing information connected to the PDU. So this is where the protocol data unit goes through. If I go back to the UE for a moment, the protocols down here once again, this is where my application layer. These are the service protocols. Out of all of them, this one is the most interesting, SDAP, Service Data Adaptation Protocol. I'm pointing this one out because it's brand new. Well, as you told me, you are not so familiar with 4G, so that's fine. But I'm always interested in the differences between the previous system and the current system, because wherever there is an extra, it usually implies a new feature. And new features is what I'm interested in, because they are the reasons why the operators are deploying their network. So I would like to point out the SDAP here on the protocol stack picture, and later on return to it. This has something to do with what is called in 5G end-to-end quality of service, which by the way is a misnomer, but there are some concepts how to correlate quality of service within the radio network and in the core network between the new PFs. This is a new tool that the operators got for their use. All the protocols underneath here, same as the ones here, they have the same names as they had in the previous systems, and they are not that different from what we had previously. So they will not help us with the extra reliable services, with low latency, with the orgs in general. Then, interconnecting the radio with the core network, we said this is the N3 interface, or NGU as called by the radio people. And here you can see a shape which I hope makes you think of the tunnel that we mentioned yesterday. This is a GTP-U tunnel, and as we said, there is one for every PDU session that will be established. Please notice, a moment ago today I said that within one PDU session you can have a number of data streams. But I am now making a statement that whatever different data streams we define for this communication, they will all be pushed into one tunnel on the N3 interface, which means I will need to have some identifier for each of the data streams. which is a good news really, because the moment you have a unique identifier for a particular data stream, it means you can differentiate between this data stream and all the others. And this opens up for having dedicated quality of service for this data stream, dedicated charging, dedicated routing rules. We'll talk about the user plane later on. I will show you how all this is set up, but this picture is a good place to mark certain things for later analysis. So, you have the protocol stack over here, and I wanted to show it to you because on the fold-out yesterday, maybe you've noticed, when we were talking about all these different network functions, we said that we are using HTTP on this bus in service-based architecture, and I also mentioned over here the names of the protocols that are used in different places when we want to either control the user plane or have the user data sent on the user plane. So this is just an elaboration on these very small remarks over here. Please notice NGAP was mentioned on the slide I showed you a moment ago. This one wasn't. I will return to it later on. Packet forwarding control protocol is the session management function telling the UPFs what to do. And please notice one more thing. Yesterday, I did put a disclaimer, but I said, let's say that UPF is a router to simplify matters. But according to what we mentioned over here it says that we have different types of PDU sessions in 5G. And IP session is only one of the possibilities, or actually two, because an IP session can be version 4 or version 6. So if I have an IP session, then yes, this user plane function is a router. But if I have an Ethernet session, well, not necessarily. This is something we will dig into today after I am finished with this fold-out, because there are a few more things that I would like to tell you. So, first of all, we saw a little bit about the languages that are used in different parts of the 5G system. And now, using that language, I would like to return to me waving my hand yesterday over here saying, you will tell the network, hello, I'm here, performing 5G registration. And to have a look at this 5G registration, I will ask you to look in a slide, which is still in chapter number 2, but this one is earlier than the one I showed you a moment ago. This is slide number 3, and then on slide number 4, I'll show you the traffic case. And first of all, again, the most important information, if you need to know more, this is your reference. So you can see here, document 23502. This is a document in which you can see all the signaling traffic cases in the 5G system, and chapter that deals with the registration. This is one over here.
Hello.
Now, the term registration, especially if, as you said, some of you work with the MTAS, which means Voice over LTE, services for voice communication. The word registration will be familiar to you. There was a SIP registration when we wanted to start an IMSE communication. Now, this word registration in our 5G context means an attach of the mobile device. And why does the UI perform an attach to the network? Why does it say, hello, I'm here? Because the network needs to verify that the UI is allowed services, remember, in a particular area. Then we would like to start mobility tracking for the devices that are not stationary. So the registration triggers for the mechanisms that allow the network to know where is the device at a certain point in time. And reachability. It's a very interesting term in 5G, actually also in 4G, but here it is very prominent. When I ask people, do you understand the word reachability? Everybody always says, yes, of course. I think the main reason for that is that the engineers I usually work with, they've been working with mobile networks, and everybody heard of call forwarding on unreachable, for example, service. So somewhere in our minds, in most cases, there is a belief, there is an understanding that a UE that is not reachable is a fairly seldom situation. It's when I as a person enter an elevator and I have no coverage, when I go down to the cellar in my house over here, when I put my device into airplane mode, when I get on an airplane, if they are not grounded the way they are at the moment with the COVID. I just would like to shake us out of that belief, of that perception. Please remember, in 5G I want to shift focus from people to devices. And now, if you think about my water meter down here in the cellar, my water meter says how much water I have used up throughout a month. It does it once a month, and it sends just a little bit of data. It does it at the server. Now, if we think about it, on the other hand, you remember we said that we want to save on energy. I want to save the battery of the device. I don't want to have to change the battery every day or even every week. If you look at the standards with requirements, some devices, there is a requirement that the battery should last for 10 years, like traffic alliance or my water meter here. Now, for that reason, in order to save on the battery power, a lot of IoT devices, both in the 4G environment and in 5G, try to focus the network on so-called power saving mode, a group of features that will allow this device to switch off its receiver and transmitter for long time periods to save its battery. But then when the transmitter and receiver of the UE is switched off, it doesn't report to the network very often that it's still alive or where it is. And what's more, it doesn't listen to paging. And when you don't listen to paging, then this device is not reachable. Which means in a mobile operator's network, with the advent of IoT devices, they suddenly realize that they have a big group of subscriptions which are unreachable for very long time periods. And this has consequences. So, just to mention the meaning of this word, because it's in the context that it was used earlier, it's maybe not so obvious. Now, a UE will perform this attach procedure, hello, I'm here, if option number 1, initial registration will be done quite obviously when I come up to a new network, when I was in airplane mode. It's like the first contact with a particular mobile operator's network. Here we will set all the parameters that are relevant later on for the UE's behavior, for its mobility, for the rules to set up PDU sessions. So this one is like the attach that the UEs have been doing since the GSM time, saying, hello, I'm here. Then another type of registration is when a UE does so-called mobility registration. And mobility registration means the UE enters a tracking area that is outside its current registration area. Registration area is defined by the network, and it's information to the UE sent to it when the registration is accepted, saying, as long as you move within these boundaries, I don't need you to do mobility updates. But the moment you cross that border, I will want to see a mobility registration. Then, periodic registration, you probably know it par analogam to previous systems. Periodic registration is the UE sending to the network, I'm still here, if there was a period of inactivity. So it's based on a timer that the network provides to the UE. These timers are UE specific. It makes sense for a smartphone to do a periodic update, I'm still here, every 2 hours, for example. That if it's the water meter, maybe it's enough if it does a periodic update once a week. And this brings me to a remark I made earlier when I said in the 5G system, through the network exposure function, which is a border security node, you will allow customers of a mobile network to push information into the 5G core about the behavior of the subscriber. Because if the water utility company tells the operator, my subscriber will only send 15 octets once a month on the 25th of every month at 2 o'clock at night, then it is much easier for the operator to network size that fulfills the particular need. And the last one over here, UE will also perform registration when it needs to inform the network that its capabilities have changed, its protocol parameters that were initially negotiated have changed. There might have been some over-the-air firmware upgrade of the water meter, and if this affects anything that was agreed in the initial registration, the UE will inform the network about that. So these are the reasons why the UEs might want to do a registration. And if we look at the next slide, you will see this is slide number 4 in chapter 2. You will see that the example I have chosen is the initial registration. So it is not the general picture that is always true. It's just the scenario when the UE comes to a brand new mobile operator's network. Here in this example, my UE is simply switched on. It chooses a PLMN, which is the operator, and the access network. And you can see here, my UE made the choice to use a certain radio access network that has this antenna, which implies 4G or 5G, so it could be a G node B or an E node B. Access network selection, the alternative would be Wi-Fi. But in this scenario, I'm talking about standalone, and this is my new radio. Now, the UE sends over here the registration request. This is a non-access stratum signaling message, so it is supposed to go all the way up to the access and mobility management function. So we will see the registration request coming to the AMF in a moment. But for now, the message that was built by the UE, what type of registration is it? Initial, mobility, or periodic? Then the UE needs to identify itself, and it will either send the concealed SUPI, encrypted SUPI, or it will send the globally unique temporary identity to the network. It will send its capabilities, and if anything sent here changes over time, it will do another registration. And here it says requested, and this is a new abbreviation. We will have to talk more about that later on. But for now, you can see the abbreviation, what it stands for. Network slice selection. You hear it. Network slice selection. Assistance information. The UE indicates to the network that as we are going over here to choose network functions to serve me, I need these network functions to serve a particular type of network slice. So he can indicate, I want to use enhanced mobile broadband, or he can indicate, I want to use the massive machine type communication slide, massive IoT. And this one over here is also very interesting. A UE sends a PDU session status. And if you look at it the first moment, it seems obvious. I mean, a PDU session is either active or inactive. That's it. But when you think about it, look what's happening here. A UE that is doing a registration, which should be the first thing it does, can inform the network that it has an active PDU session. The first time I saw it, I got a little bit lost, to be honest, because why? And only later on, when I started digging into it, what does this mean? It means that this UE might have already an active PDU session over a different access network. So here it is doing registration over this access network to the core, but it knows that this core already had a registration from earlier on. There was a PDU session established, and I don't know whether you see it, but this in effect means a handover from non-3GPP access to 3GPP access, from Wi-Fi into either LTE or new radio, 4G or 5G radio. So this is my methodology of moving a PDU session. Of course, if we think about it, this procedure takes time. So this type of handover is non-real time. It will not be a good solution when we do video streaming or when we do any live streaming, but it can work for some other types of PDU sessions which are non-real time. Now, this registration request goes into the, let's say, G node B, if the radio access network is 5G. And then this radio network over here has to choose the correct access and mobility management function, the one that belongs to the requested network slice. So you need to have some pre-configured data over here. And then the G node B will forward the registration request with the parameters we've seen earlier, adding network identity, location information, cell identity, and radio access technology type, which means that what gets into the core network is information. Where is the UE, what access network it is using, and what operator it is using. Next, the access and mobility management function over here will start with the security, and security means verifying that this is a valid subscriber. In order to do that, we need to contact the authentication server function. So you can see over here that the AMF will talk to the authentication server function saying, can you please give me credentials to perform authentication and key agreement. Remember, we need the keys for encryption and for integrity check procedures. So this has to be pulled from the authentication server function. And another thing, if you look over here, the UE might send the concealed identifier. It's the UDM that can do the deconcealment. So there is communication to the UDM to do deconcealment if needed. If it's the 5G Bluetooth, we don't need that. And another thing is, well, you probably remember that hidden behind the unified data management is the UDR, it's the actual database, and it's the database that holds the original subscriber-specific key from which we will derive the keys and later on provide it to the relevant elements in the network and to the UE. So the AMF initiates authentication and security procedures. It involves the relevant elements, and when it gets everything it needs, it sends a challenge to the UE saying, you need to answer this question before I will allow you the usage of that network. The 5G authentication and key agreement, as I told you, towards the end of this course, I will want to talk more about security in 5G. We will return to that, especially that there was a remark about interest in security, both for the microservices and for the UE over here. Now, if I continue, do you remember that we said in the 5G system we will include the policy control function during the registration to check for the access and mobility management. So this AMF over here selects UDM for communication with the UDR. The AMF will register itself in the UDR, which means after this point in time, in the central database, you will know which AMF is handling the user, which means if later on we would like to talk to the UE, we know through which AMF to route the requests, and the AMF will retrieve subscription data from the UDR. And in this subscription data, it might say that we have the need to do access and mobility management policy control, which will mean that this AMF over here will have to talk to a policy control function to get the access and mobility policies. And now please notice how many times on this slide it says select AMF, AUSF, UDM policy control function. In each of these procedures, the requirement is that the selected network function has to belong to the correct network slice. And if you maybe remember from yesterday, we said that we have I compared it to a DNS, right? We have a network repository function in which every single network function, once it's active, if we talk about virtual environment, it means it was instantiated. So the moment the network function is instantiated, it registers itself in the network repository function. And then a network function that needs to find the correct AUSF can ask the network repository function, please give me the address, where should I send this information? And here talk to the network repository function to know which UDM to talk to. And here talk to the network repository function to find which PCA is people. Now, once the AMF has checked everything that needs to be checked in the database and in the policy manager, we will have in here a registration accept, where you inform the UE. Now, this is going to be your temporary identity from now on. This is your registration area. This is where the network says, as long as you move within this region, you don't have to do mobility updates. Mobility restrictions. This is based on what the policy control function tells us. So you tell the UE, you are accepted here, but if you move to a different region, then, sorry, your registration will not be valid over. Periodic registration timer. How often should the UE say, I'm still here? So a smartphone every 2 hours, for example, water meters every week, for example. PDU session status refers to the request from earlier. If we are moving a PDU session that was started over Wi-Fi, the network can either accept that or reject it. Allow the network slices in this area. This is information for the UE. This is the list of slices from which this UE will later on be allowed to choose when it starts a PDU session. And these allowed network slices depend on the subscription data for the subscriber, but they will also depend on what slices are supported by the operator that serves this user. Because if it's a roamer, then not necessarily the visited network supports the slices that the roamer might want to use and even is allowed to use. So that's the allowed network slice selection assistance information and indication whether in this particular area this network supports voice over 5G. IMS voice means IMS control of voice streams, data stream going over packet switch. So IMS voice over packet switch. If this flag is set to yes, then it's going to mean you can start voice over 5G types of sessions in this environment, in this region that you have registered in. So that was the registration, and I'm putting it here because I would like us to get the picture that the moment the UE says hello to the network, certain network features, certain parameters are distributed between the relevant network entities and also sent to the UE. So anything that happens afterwards will have to take what was negotiated here into account. But it's also preparation. These parameters have already been distributed, which means we will not have to do it every PDU session is started. This is preparation work, basically, for sessions later on. Plus for mobility camp. So that was the registration procedure over here. And then we also said yesterday that after the UI is registered, there is only one service available for it, and these would be SMSs, but that we can expect a lot of, probably majority of the 5G subscriptions will also want to start a PDU session. Whether this happens directly after registration or sometime later when there is actually data to be sent is left open to the application configuration. But we did say that if a UI wants to start a PDU session, that's this green line over here, it will send a session request to the only core network function that it can speak to, which is the AMF. And then the AMF will package that into HTTP over the N11 interface and send it to the session management function, which is the one responsible for naming the keys. So, PDU session establishment, a little bit more in detail compared to what we said yesterday. And I would like to ask you to look, I'm now moving over to chapter number 3. When we look at the slide, it says over here, chapter 3, slide number 2, because as you might guess, I'm easing us into the next folder. Before we go over here, PDU session establishment defined in that document in this particular chapter, and it can be a UI-initiated PDU session establishment, which is, I would say, a normal case. The application wants to start a new user application. But it can also be a procedure used because the UI wants to perform a handover between a 3GPP access. This would be LTE or New Radio. LTE and New Radio are the 3GPP accesses in the NG RAN, the radio access network, or non-3GPP, which is Wi-Fi or fixed access. So we can have handovers between different types of accesses. Of course, they take time, so they are not very good for real-time applications. Then, PDU session handover, look at this. This is a handover between evolved packet system, 4G, and 5G system, 5G. But this is about the core network. It's not only about changing the radio access, but it's also about changing which core network is responsible for the session. Operators can and probably will, for a certain time, run in their networks the 4G and the 5G core in parallel. It makes sense, especially that we have to remember that there is a number of equipments out there that only speak 4G NAS, so they need to have the evolved packet core to talk to. But we can make handovers between these two things. This is UI-initiated session establishment. There is also a possibility for the network to trigger a PDU session establishment, but what it really looks like is the network triggers the UI to start a PDU session. So there is a trigger message to the application on the UI side saying, I want you to start a user plane connection, because in effect, a PDU session establishment is always a procedure initiated by the user equipment, but the network can ask for that to happen. SMSs are a very useful tool for UI triggering. And if you look at the next slide, please, chapter 3, slide number 3, again, there is a number of scenarios possible, as we said, but we will be looking here at the UI requested session establishment procedure. And this UI is already registered, as you can see, and it will send out a non-access stratum message called PDU session establishment request, in which the UI will tell the network, I want a PDU session because, so is it a handover or is it an initial connection? Requested PDU type, IPv4, IPv6, Ethernet, or unstructured. The UI can say what type of session it wants to start. The UI will allocate the session identity and say which slice will this session belong to. This one is single network slice selection assistance information, and this is a unique pointer to what kind of slice the UI wants to use for that session. Do you hear what I'm saying? A certain 5GPDU session has slice definition as its attribute. It is established at the beginning of its session and it cannot be changed. Every session belongs to one and only one network slice. Then something called SSC mode. This is session and service continuity mode. And maybe this word continuity rings a bell for you. This is basically an indication from the device to the network what should happen with this session as the UI moves around. Session and service continuity. Of course, we'll have to talk a little bit more about that. The UI location and the access technology type. What access am I using? Fixed or mobile? If it's mobile, it's 3GPP or non-3GPP and so on. Again, select session management function. The AMF will go to the network repository function asking, listen, the UI wants to start a session in this network slice. Which session management function can handle that? And then we will send up a request to the appropriate session management function with whatever the UI told us, with the device's SUPI. This SUPI was in the AMF since registration. It wasn't sent here because, as we said, a UI never sends the permanent identity over the radio. But the AMF has it since registration, so you will provide it to the session management function, and you will see, and it's me that is talking, you will see the address, if I might call it that, the AMF identity here. And this means that this PDU session establishment request, this last message over here, it was packaged and it was placed into an HTTP message over here. And you can see how do they describe what message should be used in the 3GPP standards, the one that was quoted on the previous slide, 23502. Capital letter N for the 5G interface. Service producer is the session management function. We're sending a request to the session management function. Then after this underscore, remember what we wrote yesterday? In the 5G core, a network function, which is the service producer, gives a network function service to the consumer. This is the name of the service. They are defined in the standards. I can compare this to your microservices. Session management function does a number of things, but this is a group of functionalities about a PDU session. So this is the name of the service. And then over here comes the operation, which is a message name. Here it says create session management context, and it's a request. And by the way, if I ever show slides where you see communication between network elements, I took a notation from the 3GPP standards. When you see an arrow that is full here at the end, it means it's a request. Arrows which are empty, we'll see them later on, means responses. So this is a request from the AMF to the SM. Then the session management function will do exactly the same thing that the AMF did during registration. So it will send its address to be stored in the central database for future incoming communication so that we know how to reach the UI, and will download this part of subscription data that is relevant for the session setup. Remember, in the UDR, which is behind over here, Unified Data Repository, we had 4 groups of parameters that can be stored. And when you retrieve data from the UDR, you don't necessarily download absolutely everything. So here, all this encryption data relevant for the session management function during the establishment. Of course, the full list is defined in the standard. And then, when the SMF contacts the central database, what will be stored? The devices should be the session management function identity, who was talking, and this one over here appears for the first time. Yesterday, when I was talking about connecting to a data network, I used the term APN, access point name. You might know them. This is the definition of where to connect to for the application. All the operators basically support APN internet, so you can have generic internet access. Some big corporations have dedicated APNs on certain operators' network. For example, Rogers in Canada, who's an operator I work with a lot, they have a number of corporate customers, so they have thousands of APNs for these customers, like FedEx.com and so on. Now, APN is the term from the previous systems. This connectivity to the application address in 5G is called data network name, the DNN. It has the same format as APNs, if you know what they look like. And one more remark. Very often in the standards, you can see statements like that. UDM stores something. Please understand that this is from a language perspective. The word stores doesn't necessarily mean stores locally. What really happens over here is that the UDM will send these parameters to be physically stored in the UDR. So it performs the storing action, but not necessarily locally. Now, once this is done, the session management function answers the AMF. You see this arrow here is empty at the end. It's a response. This is the SMF video session create session management context response. And here you have some kind of a unique identity sent down to the session management function. Now, we will want to connect to a particular data network. So, the first thing that the session management function will do, look over here. Talk to the policy manager, called policy control function in 5G, in order to download policy information about sessions. Same thing that the AMF did earlier. AMF downloaded policies for access and mobility management. Session management function downloads parameters for session establishment. Interestingly over here, please notice that the session management function, it says here, performs PCF selection, which means the policy manager used by the session management function at session establishment might be different than the policy manager that was used by AMF during registration. So an operator can separately run policy control for access and mobility management and have a separate group of virtual machines or containers called the policy control function for the sessions. Now, the session management function, based on the information provided from the UE, which was sent to us over here, will choose the correct session and service continuity mode to comply with the request. What should happen with the session as the UE is moving? We'll talk more about that. We'll choose one or more user plane function, and if it's supposed to be an IP type of session, needs to allocate an IP address. And the same remark as previously, when it says in the standards it's responsible for allocation of an IP address, it doesn't necessarily mean that this session management function needs to physically have a pool of IP resources to allocate. This can be a Radius client, and you can talk to a Radius server. This can be a DHCP client, and it can talk to a DHCP server to get the IP address and then provide it down to the UE. Now, once we have chosen one or more UPFs, in this picture there is only one UPF to keep it simpler. The session management function speaks to the user plane function. This is the SMF controlling the UPF. The interface is called N4. The message is an N4 session request. And the session management function will tell the UPF if you have an incoming packet that fulfills these criteria, so packet detection, originating IP address, destination IP address, source port number, destination port number, this kind of information. It's a packet filter. So when you detect that a packet belongs to a particular flow, service data flow, then this is what quality of service you should apply, forwarding, and what I want you to report upon. We'll talk more about that. This is establishing the user plane in the core network, because UPF is part of the core network. And as we said, we are using GTP, GPRS tunneling protocol. Therefore, the UPF sends here the core network tunnel information. It's just an identifier of the logical connection. So whenever you say the UPF to work with tunnel number 15, it will know which part of the definitions it should possibly change. So here we have established the information to the UPF, and if we continue to slide number 4, then the session management function will also want to talk all the way down to the radio network and to the UE. So you can see here the command goes from SMF to AMF. There is also a response. We are using the AMF as a service producer, so it says here an AMF. We are addressing AMF, the service communication, and then the operation, the actual message, N1 and N2 message transfer. Now, what is this N1 and N2 message transfer? N2 was the name of the interface between the AMF and the access network. So, N2 session management information, these are all the parameters that need to be sent to the radio access network so that it knows what kind of resources to establish. Like tunnel identifier on the UPF side, quality of service, forwarding rules, and so on and so on. So this is a description that goes to the access network. The other part of the name, N1 was the name of the interface that is going, N1 is the name of the interface that is going all the way down to the UE. So what it says here, N1 session management container, this is supposed to go to the UE. So the session management function asks the AMF, please tell the UE, and here you see PDU session establishment accept that will go all the way down to the UE. So this is SMF asking the AMF to send the relevant parameters to the access network and to the UE. So now the PDU session has been agreed upon. There is an answer over here from the radio access network. Yes, we are ready for that. And this allows you to start sending uplink data because all the resources are in place, while the information from the radio network that comes into the AMF that controls it, you see here access network tunnel information. This access network tunnel information, the AMF will forward through the session management function to the UPF. So now this user plane function knows what is the tunnel that the radio access network is using towards it. This is the one and only tunnel for the whole PDU session that we mentioned earlier on. And this communication to the UPF is acknowledged by the UPF, and then this request from the AMF is acknowledged over here. Nothing more to say about it, it's just to show that we have responses to the requests that came here, and after that downlink data can also travel all the way down to the UE. So Yeah, we can subscribe to events. I forgot about that, but this is the standard thing. So this is the PDU session establishment, and as I said, we are very focused in 5G on security. So please just look at the remark over here, and I'll return to it later on. We can have a secondary extensible authentication protocol. That's what it stands for. Secondary EAP-based authentication and authorization can be performed. We saw the ACA, remember? Authentication and Key Agreement, Credentials, Authentication Server function. This was activated during registration, but here it says that when you establish a session to a particular application server, maybe this application requires another authentication. So there will be a data network AAA server that can be involved in that procedure. And this basically is like, fine, when a water meter wants to talk with the network, BGP network, we will have authentication and key agreement performed by that network. But later on, when this water meter wants to talk to the application in the water utility company, there might be some kind of username password verification on the application layer. And the 5G core network has support for that. We'll talk more about this later on. I want to take the security topics in one go at a separate folder at the end of the course. So this was just to finish off a few things from the foldout that we were doing yesterday. I hope it clarifies matters. And the same rule as we had yesterday, I will be making a break on the hour, which means now is the time for it. So I will start the timer in a moment, same rules as previously, 15 minutes break, during which if you have questions, you are welcome to talk to me. Otherwise, I see you in 15 minutes from now. Well, okay, I'm still here. As we said, we have covered the 5G core network overview. I used this architecture picture to discuss some features of the 5G system to show you basically how it works, what happens. And from now on, what I'm going to do, as I mentioned yesterday,
Jó, figyelj csak, azért tudunk beszélni ma valamikor, meddig van tréninged?
Into different parts of this foldout. And the first step that I would like to take in this manner is to look a little bit more at what over here. So if I could please ask you to look at the next foldout. I hope the title is PDU session types. With, as always, a reference to where can you find more information on that, if you'd like it. And by the way, I just remembered, I had a question after.
Azt terveztem, mert nekem meg pont akkor lesz vége a tréningnek. Van egy fél órám, közben ebédelek, és akkor gyorsan 2 mondatot akartam vele dumálni. Jó, oké, köszi akkor.
Whether you have access to that. And as I answered, but I guess more persons might be interested, I should have said that at the beginning, I'm sorry, I forgot. The filled-in foldouts will come after the course. So you will have a digital version of the information that we are physically writing in.
Hát esetleg pénteken is beszéltünk róla amúgy.
Foldout about the PDU session types over here. I will keep, as you can possibly
Oké, köszi akkor, sziasztok, mennem kell.
Remarks at the top. I will keep the color code that we had earlier on. So here, control plane and user plane, they are simply to help us remember that the red color is talking about signaling and the green color is talking about the user plane topics in this particular foldout. And I would like to start with the overall look, so we understand what will happen over here. As you can see, this foldout is divided into 3 parts. The first part over here is the option when a UE, we we already know that the UE requests what type of session it would like to start. The UE asks for either IPv4 session, IPv6 session, or the UE indicates that it's a dual stack UE and it leaves the decision to the network. Here we see the option when the UE asks for Ethernet type of session, and down here if it asks for unstructured. And I would like to start with the IP sessions because we expect them to be the most common ones. And well, what will happen over here? We have this signaling that the UE sends at session establishment, and as we said, this is the non-access stratum signaling which the UE sends over the radio to the G node B, if we talk about the RAN being the new radio, the 5G, and then the AMF packages this message and sends it out to the session management function. So what we have over here, this is the non-access stratum signaling. Logically, this information goes from the UE to the SMF, but this is the actual communication path. And in the response from the session management function, we want to ensure that the UE will have an IP address allocated. So I will just put in here that the UE gets either the IPv4 address or IPv6 prefix. And looking at where the information comes from, this is from the session management function, because it's the session management function that has this responsibility. And I'm putting over here a remark that this delivery of the actual IP address can happen through the non-access stratum signaling. So this session management function can, in the session establishment response, provide the IP address to the UE, because the session management function is responsible for the IP address over here, and delivery of that can either be done over the NAS signaling, as I said, or you remember my remark from earlier on that the session management function can act as a client. We can talk to a DHCP server and we can ask for the IP addresses. And if the session management function acts as a DHCP client, it will pull the IP address from the DHCP and send it down to the UE. So this is still the delivery method. But just so that you know, there is another possibility. The UE can ask the session management function that it would like to do the IP address allocation procedure itself. The UE might want to be the DHCP client explicitly. And in such a case, the session management function will enable the UE to receive the IP address from the DHCP. And in order to do that, the session management function will talk to a UPF, and then over here I'm moving over to green because I want to talk about the user plane. This user plane function can then connect us not to the data network where we have the actual application to talk to, but to a DHCP server somewhere out there, which would mean that this user equipment can get an IP address from somewhere else than the pool of IP addresses that the operator is running. So I would like to put into here that we can also have DHCP involved. And just so that you know, the DHCP dynamic host configuration protocol is slightly different in case of the IP version 4 and in case of the IP version 6. So this is the other possibility over here. And just so that you know, there is also a possibility that the UE may have a static IP address. Static simply means we don't do dynamic allocation. This is the IP address that this UI will always be using, and this would be part of the subscription data. And I will follow here the line that the standards are taking. Physically, the address is stored in the unified data repository, but the access into that is through the front end, unified data management. So quite often you can see in the standards that they say that we push information into or pull information from UDR/UDM. That's what this notation over here stands for. So we will have the IP address over here, and then if there are all these different possibilities, somebody has to decide what will happen. So in the signaling from the device, I will expect to see the UI inform which of the above methods should be used. So it's the decision of the UI as to which of these is going to happen. Now, what else did I put in here? I was talking about the DHCP, so I added over here that the session management function speaks to a user plane function that allows us to do the DHCP query over the user plane over here. But let me retrace my steps because I just jumped over that fact. The session management function is responsible for the UPF selection and control. This is what this line over here means. So let's put in here that the session management function is also responsible for the selection and for controlling. And now we can either choose just one user plane function, and then this one user plane function would terminate the N3 interface towards the access network, and it's also the one that terminates the N6 interface towards the external customer. Or we can have a number of user plane functions. You can see them here with these dashed lines, which means it's optional to have the chaining. But if the chaining should take place, the decision is in the session management function, and then the control of all of the UPFs in the chain are in this one particular session management function instance. This one is responsible for all of them. So we can add over here the controlling lines going from the SMF to the other two UPFs that I have on my picture over here. Now, in this case, the user plane functions that I have here on my picture, each and every one of them is an IP router. So we can put in here that these UPFs are routers, and they are responsible for packet forwarding. Basically this means that we do routing decisions. We will forward the packet data units. That's what appeared on this slide with protocol stacks, packet data units. And where a particular packet will be forwarded to is based on the IP addresses, source and destination. So these are forwarding rules. And this is control of the session management function over the UPF. And if I might just remind you, we mentioned, this is the N4 interface, we mentioned that when the SMF controls the UPF, the protocol used here is called Packet Forwarding Control Protocol. It gives you the routing rules for all the routers in the chain, so PFCP is used towards all of them. Now, thanks to these routing rules, we can connect the user plane all the way out to the data network. And let's just put in here what we said, but we didn't write it in anywhere. The equivalent of the access point name from the previous systems in the 5G is called the data network name. This tells you where to connect to when we leave the 5G core and we go towards the customer. And if I just look at this green line from the perspective of the routing, I moved to the right-hand side of the foldout, and you can see over here a small picture, the protocol stacks. The service protocols down here, they are just bunched together, marked so that we don't forget that they exist. But I would like to talk about the routing principles over here. So you see the user equipment access network, 2 UPFs on this picture, and then the external data network, the N6 interface between the last UPF and the data network. And what is basically happening here when you look end-to-end at the information, if this is the packet that the UE would like to send all the way up to the data network, so this is the data packet, then the IP address that is used to route the packet is known to the UE, to the last UPF in the chain, and then in the application out here. Because if we look at what is happening between the UE and the G-Node B, if we look at what is happening between the UE and the G-Node B, I keep talking about the radio access network being the 5G, then over here, to route a packet is through the data radio bearer identity. While if I look at what is happening between the G-Node B and this UPF, to know how to route information, you will use the appropriate tunnel identity of the GTPU protocol. And this is the same over both the, this is the same both over the N3 interface. This is the interconnection between the access network and the core. And this is also true between the different UPFs in the chain. So basically, this is the N9 interface, as many of them as we have. And then, to route correctly outside, this is when this UPF has to look at the destination IP address and act as a router towards the outside world. So, as you can see, this one is for sure an IP router, while these over here, the UPFs in a chain, they just work on the tunnel endpoint identifiers. I'm referring to my statement from earlier when I said a UPF, I can simply say it's a router, but I immediately made a disclaimer. I'm lying. This is not exactly true. This is a router. We will return to it later on because it has other functionalities that put it aside from the other UPFs. And if I go back to this PDU session that we established with these means, I used a term. I just said the word, but it's well defined in the standards. I used the term attribute. And this is what I would like to talk about now. A PDU session attribute is something that describes the session. It's a parameter for the session. And the most important and the interesting parameters are these that are established during session establishment, mandatory, which means you can't work without them, and they cannot be changed throughout the lifetime of a session. So they are fixed. This is like the basic description of the PDU session. And we can see here now what are these different PDU session attributes. So, PDU session identity, a unique identifier. This one is chosen by the UE, which uniquely identifies the whole session. Information, where does the session connect to, which is the data network name. And for those of you that find this helpful, this is the same as the access point name previously. PDU session type. So in this example, in this example that we are doing here, the PDU session type here would say either IPv4 or IPv6. But as we know, it can also say Ethernet or unstructured, which we will talk about a little bit later. So PDU session type. Then, which slice does this PDU session belong to? Single network slice selection assistance information. And excuse me for a moment, don't do what I am doing now. I just want to show you something. Later, tomorrow, I think, I will talk much more about network slicing. I will explain what is this single network slice selection assistance information, and I will also explain what is this network slice selection assistance information. This appeared in registration, this appeared in the session setup. We will talk more about that, so kind of please be patient. But for now, what I'm saying is making a statement that once you set up a PDU session, you decide which slice will it belong to, and you will decide what should happen to reflect the mobility of a UE that has started with session. So session and service continuity mode. And as I said, I will return to that also. So we will see more about that. For now, I am just basically making the list of what is relevant. Then, for every session, remember that security is very important. For every session, we will decide what are the security policies that should be used for the data streams within this session. Security policies, you can decide, do we use encryption or not? Do we use integrity check or not? This is a group of attributes for this particular PDU session. So it's lifted up on a very high level. It's a very basic parameter for the PDU session. And one more thing, added only recently in the standards in release 16, is an indication whether this particular PDU session can use you see this multi-access over here? Can it use Wi-Fi and 3GPP at the same time? These are called multi-access PDU sessions, and this is just the name of the flag which says whether it's allowed for this session. Let me go back. Why am I underlining this as a new thing? Let me go back just for a moment to a foldout we did earlier on, where do you maybe remember, this was the place, do you maybe remember I said over here that if you want to have higher throughput rates available to one particular UE, what can you do? It was called dual connectivity. And dual connectivity could either mean that the same UE is getting radio throughputs from two different G-node bees, but this is in both cases new radio. Or I said that a UE can have some packets over new radio and some packets over LTE. This is so-called inter-RAT, dual connectivity, RAT for radio access technology. But what you have on this picture is dual connectivity for 3GPP access, either LTE or 5G. While what I'm saying now with this term multi-access that we have over here is that a UE can use both 3GPP and non-3GPP access for this PDU session. So So this means this opens up for a possibility that a certain application starts up one PDU session, and then you can define that one data stream goes over Wi-Fi. This could be, for example, video, because if some information gets lost over Wi-Fi, video is quite resilient to some information loss, while another part of the same PDU session might go on the 3GPP access with the whole quality of service mechanism that we have. So you can guarantee better resources. So maybe video goes over Wi-Fi, but audio or control information will go over 3GPP access. This is a release 16. This is quite a new functionality that is in the 5G system. So these are the PDU session attributes. I will have to return to the slice information and to the session and service continuity mode, but otherwise I hope we get a good enough idea of how do we describe a PDU session, what attributes do we allocate for it at session establishment. And whatever I said here is also true for the remaining two cases, Ethernet and unstructured, which I will want to move over to now. So, first of all, if I move over to the Ethernet case, some things are uniform. This is the idea of 5G being a system that gives me convergence, which means regardless of what type of session or access we want to use, we try to have uniformity in the system. So you will still see a PDU session establishment NAS message go from the UI to the session management function. You will still have the session management function over here responsible for selecting and controlling one or more UPFs. So we will have these control lines. This one is here for sure, while these are optionally. And we will also establish an end-to-end user plane connection with a PDU session having, the same attributes as what we saw earlier on. But there are differences. Ethernet PDU session. First difference, I guess you can already see. When I wrote what the session management function does over here, I can compare it with what I said earlier on when in the IP case we said that the session management function, apart from doing this, does IP address allocation. In the Ethernet case, this is not needed. We don't use IP addresses. In the Ethernet case, what happens is we are using the methodology for performing routing using Ethernet addressing and routing rules. And this means using MAC addresses. So this user plane function over here, let me put a remark that in this case, the UPF at the border of my 5G network, it is not a router, it's an Ethernet switch. And it still needs to do packet forwarding, but here the forwarding of the packets is based on the MAC addresses. So this is an Ethernet switch. And by the way, I think you might already have noticed that when I'm talking about the UPFs, which as we see, they can be chained in both cases, the user plane function, which is the one that terminates the M6 interface, is quite special. This is the one that is responsible for the addressing towards the application. So what I would like to do now is put in here a term for this border UPF, and we will talk about that more later on, but we have to put the definition somewhere. This border UPF is called a PDU session Anchor. Excuse me, let me just check. Yes. And you have this abbreviation down here, so we don't have to write it. So this is a PDU session anchor in the Ethernet case. This is my PDU session anchor in the IP case. And there are certain rules for what can these UPFs do, so we will have to talk about them a little bit more later on. But for now, returning to these comments over here, this is the setup for Ethernet PDU sessions, and it means that from the perspective of UE, we have no responsibility in the spelling problems. We have no responsibility in the operator's network of allocating any kind of address for the UE. You don't allocate an IP address for the UE because it doesn't need it. And what's more, the MAC address that the UE is using was not originated in the 5G system. It's from somewhere else. Sorry, just muted myself because I was coughing. So, another remark over here, also something that we said, but I like things written down. I mentioned the fact that what we are building here is a local area network. And this local area network goes all the way from the UE where the application sits, to the external customer. And just to remind you, the examples I gave over here, when does this make sense, is when you want to have the 5G network features, which we will be discussing, its network slicing, edge computing, and so on, in the form of a 5G in the box that is placed inside a particular building. It can be a hospital, it can be a smart factory, it can be something that is geographically contained, and it will be an isolated network with all the features that come from the 3GPP standards. In that case, Ethernet is good enough, which basically means that we don't have to worry about this extra overhead that comes with IP. You don't have to have a TCP or UDP headers, you don't have to have the IP headers, you don't have to do the IP routing decisions, which basically means that this kind of a solution works in a small area, but it's probably going to be quicker when we talk about data transfer. When it's quicker, it means we have lower latencies. This is going to be a good solution for the orgs. This is how we expect this to be used. And then the third example, the last one over here, so-called unstructured PDU sessions. And these unstructured PDU sessions, I also mentioned them earlier on, are used for giving point-to-point connectivity between the UE and the data network, where the system that we are running, the mobile network, doesn't understand the addressing protocol that is used by the endpoints. So, the remark I wrote over here, 5G system is transparent for a protocol X. Transparent means you don't understand it. You can help this information be carried through your elements between the endpoints, but you yourself within the 5G system don't understand it. And this protocol X is the one that is used for addressing and routing, but within the application domain, between the server and which exactly water meter, for example, it wants to talk to. So if we just put over here on the right hand side where we have the routing information, this protocol for addressing is only known in the endpoint, while all the elements over here, excuse me, are using for addressing the same principle that we have here. A data radio bearer ID between the UI and G-Node B, tunnel ID all the way to the PDU session anchor, and then the PDU session anchor in the unstructured case simply has yet another binding to a particular VPN tunnel or whatever we use to talk to this particular the service user that we are servicing over here. So in case of the unstructured PDU session, here in my example G-Node B, I have a binding, how to show it, here I have a binding between radio bearer ID and tunnel ID. Here I have a binding between tunnel ID and tunnel ID, and here I have a binding between tunnel identity and whatever is used to connect to the data network, while only they know which exactly of their subscribers they are talking to. It's their identification. It can be based on the gypsy or it can be something completely different. We, in the mobile network, we don't know. But we can manage to do the routing as a point-to-point connection. And we are just a blind transport network. So we can put over here that in this case, the PDU session anchor, which was activated due to a session establishment request by the session management function, this user plane function that acts as a PDU session anchor, it is responsible for mapping all the packets of this particular PDU session to some kind of an external data network address. And this is referred to in the standards as a data network access address. As I say, it can be a VPN connection, VCI, VPI pair, different ways of handling that. This has been around for quite some time as an overall technology. Now it's pulled into the mobile networks. And as a result, we can have this user plane that is established all the way between the UI and this data network, with this PDU session being unstructured. And this use case opens up for the mobile operators to offer a point-to-point service, which doesn't have to be IP, doesn't have to be Ethernet. These devices don't need to have MAC addresses. We handle this differently. So it's simply a different use case, a different type of service for applications that might be happy in such an environment. So if we look at this fold-out altogether, I have explained, I think, PDU session types. They have appeared over here in the previous fold-out. We said that a PDU session can be of type IPv4, IPv6, Ethernet, and unstructured. I talked a little bit about the most interesting technological aspects, depending on which of these we have chosen, and I also tried to give you an idea why would a UI, an application, want to have this or that, or in which cases is it useful. But for now, I am ticking this off. I assume that I have covered that part, and I will want to move on to yet another topic. And this yet another topic, maybe before, I mean, you can open up the next folder if you want to, but this yet another topic that we have over here, I said that we need to talk about session and service continuity. I would like to talk about mobility of the UI, but before we talk about mobility, I would like to talk in general about what do the PDU sessions look like in 5G, but now from a routing perspective. Because if you look at any picture I made until now, maybe this is better. Any picture that I make now looks like a PDU session is basically linear, right? So we use a radio interface, or as we know, if there is dual connectivity or if there is multi-access sessions, you can have more in parallel of these lines over here. Then there is one connection from the radio network to the core, possibly a number of chain UPS, and we get out here. This is linear. It looks like a line if I just zoomed in here and made a chain of UPS. But this is not the full picture. So what I would like to talk to you about now is, if you look at this next foldout, it is the possibility of word number 1, splitting the user plane. Splitting the user plane. Split. And you have a picture down here where you can see this funny, it looks like a fallen tree with branches. This part over here, this is one PDU session. But what I would like to show you is that we can, if we want to, create one PDU session with a number of branches, all of them active, each of these branches used for a different data stream. This is the word splitting. The second word, relocating, implies movement of the UE, which means once this UE established a PDU session, either with branches or the linear one, what happens when this UE moves around? So this will be my next topic. And I know that it's almost time for a break, so let me just put in here, so that we know where should we get started. Let me just put in here on the foldout on this lower part of the picture. This is my PDU session, and now if you look, I'm still using the green color for the user plane. I hope you are used to that by now. This is a network architecture picture. This is just a symbolic representation of that. And the key thing to understand here is that this is one session, one PDU session. And when it's one PDU session, excuse me for a moment, it means that we have one PDU session ID, data network name, session type, slice that we are using, SSC mode, security policies, and is it allowed to be multi-access. These values are identical for each of the branches because it is one PDU session of a particular UE. And just so that we understand, why might you want to do something like that? Well, maybe within one PDU session we have an application that on one hand wants some kind of a generic internet access, and then this generic internet access should go to some place, physically, geographically placed somewhere with certain quality of service parameters. And then maybe we have, as part of the same application, access to something that has its own quality of service requirements. So maybe I'm trying to come up with names that will not be product placements. So these are just artificially created names of services. Maybe some kind of video tube with certain quality of service and a certain exit point. And maybe this exit point, remember edge computing, maybe it should be closer than this exit point for the general internet access. And here is another branch, maybe with different quality of service, and again the routing is different, some different thing. I called it UCC fiber, whatever. So this would be the reason to have the splitting. And what I will want to show you is how can we do the splitting, what tools do we have for that purpose. And then later on, I will also want to talk about what needs to happen when the UE moves around. So we need to talk about establishing the PDU session and then about modifying the PDU session due to, for example, mobility. Because changing around the network elements that we will use for this PDU session is not necessarily just because of the mobile moving around, but this is one of the main reasons. So this is what will happen. This is what will happen after a break. As I said, I try to make breaks exactly on the hour, just so that you can clear your mind. So I'll start the timer in a moment. The break will be 15 minutes long again. And if you have remarks or questions, talk to me on the chat or directly.
Hi guys.
Yes?
I have one question. That means that we have multiplied.
Exactly on the next thing that I will want to talk about. The fact that you can have multiple session anchors means that we will need to have a tool in 5G to handle that. And we'll do that after the break. As we were saying earlier on, or actually as I was saying earlier on, the foldout that we have here in front of us is going to talk about two things. I would like to start with the first one, which means splitting of the user plane. So I will use this small network architecture picture over here for illustration. I have over here UE that has one PDU session. I keep underlining the fact that this is one PDU session, and this PDU session is going to one data network. And in effect, we already said that, excuse me for a moment, because we said, well, as it's one PDU session, then these PDU session attributes have a certain value, each and every one of them. And amongst them, there is the data network name, which means that if I look at this connection over here from the UE, it goes over the radio through the radio access network. And if I do the splitting picture over here, then it means, and now I'm going back to the question that Balázs asked at the end of the previous section. This green line split in this particular UPF over here, you can see this is one data network over here. This is the data network name, A. But if you go out through this exit, or through that exit, when I say exit, I mean the N6 interface, I'm going to end up in two different geographical placements of application servers within the same data network. And yes, just as Balázs pointed out, it means that I can have two different, in this picture, two different PDU session anchors simultaneously active for the same PDU session. Yes, this is exactly what it means, which means that the session management function over here that controls all of these UPFs, it has to tell all of the UPFs what to do, which means telling the user plane functions that act as PDU session anchors how to route the information on the N6 interface towards the outside. But it also has to inform this user plane function over here, the one where the splitting is actually done, that some of the data packets need to take that path and other data packets need to take this path. And the basis for that decision is going to be, well, whatever the UPF uses as a router or as a routing agent, I should say, to determine how to forward the packet. So this can be based on the IP addresses, on the port numbers, on the packet filter that classifies an incoming packet as belonging to a particular data stream. So this session management function over here have to tell the UPF how to do the splitting. And this is what I would want to talk about a little bit. What does this session management function do? So maybe we can start by filling in some information under the title. The session management function, which is responsible for controlling the user data path, and it can do it in such a way that we created initially. Please remember, I'm at the stage when I'm establishing the PDU session, so it's just the very beginning. So you can create a session which has simultaneously multiple, and now I will write in here, there are two terms or two descriptions that can be used in the standards. You can see that sometimes they say you will have multiple PDU session anchors, which is what Balázs mentioned, or sometimes they say we can have multiple N6 interfaces. And you know what, whenever I see a new network feature, I always ask myself a question, why was this defined? What do we gain? What's the purpose of this whole exercise? And one purpose is to do, in the standards they call it optimize the traffic handling. And maybe you noticed, I actually do try to use English words that are that represent what I want to say, but are simple. I don't really think making things too complicated is useful. But I will sometimes in this course put in very high-level terms, because this is exactly what is used in the standard. So if you need to read more about that, if you put into the 23501 exactly this as a search string, optimized traffic handling, then you will be able to read the sections that refer to that particular feature. But this is what they use in the standards. What it means really is basically that certain data streams can go to certain physical locations. And referring to what we mentioned earlier on, a typical example of where this would be useful is if you want to do multi-access edge computing. We said that the edge computing variant that is used in 5G is called MEC. And excuse me for a moment, do not do what I'm doing now. I just want to show you that edge computing is actually such an important feature in 5G. It's for the low latency applications, but we will have a foldout where we will deal with edge computing, and it will be coupled with a similar concept, how to do local area data networks, localized services. So edge computing as such, we will talk about later on. But for now, if we have the overall understanding of what edge computing can give us, then I think saying that we can use the splitting of the user plane as a tool for edge computing should be understandable. Because if you look at the picture I made over here, this one PDU session that consists of these two green lines, you can probably see that this green line over here kind of terminates closer to the UE. This could be edge computing. So this could be for me watching a football game live, while control of do I have subscription to watch this kind of sports events and so on, this can be done remotely from some kind of service provider that I have back in Poland, for example. So if I'm a roamer, I can download the game from some local server rack that is, when I start traveling again, wherever I'm going to travel for my courses, but this is the remote handling. So this is the optimized handling of routing decisions. Then, the other example, what is splitting and relocate is what is splitting good for, is edge computing gives me edge computing helps me handle these services that require low latencies. But apart from that, when we're talking about the orgs, for example, I mentioned that some applications need very, very high reliability. And one of the tools to give reliability is redundancy. If you want to make sure that every single bit reaches a certain application, a very simple way of doing that, which is quite costly, but it's easy, is to send to or from this UE not one copy of the information, but 2 or 3 or 4. I, for example, know of an operator that made a dedicated transport for a service for the military, where they had very high requirements on the reliability of the system. It's, of course, an isolated solution, but it's based on 3GPP standards. And in that case, the data stream was tripled. So redundancy is a tool for reliability, but of course not only. I mean, this is also a general tool for the mobile operators to be able to switch between different pieces of equipment if needed. I'll come back to this switching remark in a moment. But basically, redundancy is, for example, for increased reliability. So this would be another reason. And another one is multiple N6 interfaces. Now I would like to talk about the feature is referred to in the standards as flexible traffic handling. Again, it's a search string that you can put into the standards if you would like to. And most commonly, this is referred to, this is referred to the SSC modes that we have mentioned. So I can put up the full name now. SSC mode is called Session and Service Continuity. Session and Service Continuity. And in order for this remark to become clear, I will need to talk about SSC modes for a moment. And to do that, I will ask you to please look at this slide. We are in chapter number 4 now. This is slide number 2 in that chapter. Again, reference, where is it from? And first, just to point out how did we get to talk about these topics. When we were talking about the attributes of a PDU session, we actually put them into the foldout. Here you can see the source of that information. So it's a table in the 23501. And among these various attributes over here, one of them was called Session and Service Continuity mode. Now, what is that? SSC mode, I was just using a descriptive way of talking about that. I said session and service continuity are rules. What should the network do with a PDU session when the UE is moving around? Here you can see the definition from the standards. SSC mode are the principles of relocation of, and now here it says PDU session anchor during the lifetime of a PDU session. So, session and service continuity mode is not about handovers on the radio. These also handle mobility of a UE, correct. It's not even about changing these UPFs that are somewhere in the chain, because as the UE moves around, you might want to change the UPF that it is using that's connected over N3 to the radio. No, session and service continuity is only about changing the PDU session anchor. So Balázs, not only in the PDU session you can have multiple PDU session anchors, but you can also change them during the session lifetime. And one of the reasons for that would be to follow the movements of a UE. If you want to have edge computing, if you want to have content close to the UE, but the UE is moving, then as it moves out of a certain region, you might want to switch the PDU session to start using a different server rack that also has the football game that I want to be watching. That's what it is about. And I keep using the term mode. So let's explain what that is. Again, you have the source over here. This is slide number 3. In the 5G standards, we have 3 different SSC modes defined. SSC mode 1. When you define a PDU session anchor for a session, or a number of them, when you define the PDU session anchors, you do not change it throughout the lifetime of the PDU session, which means this is like stationary. It's the simplest possible approach, which means as the UE is moving around, the PDU session anchor has to stay in place. It's easiest for the network, but it also means that as the application moves away, the PDU session anchor that serves it can get further and further away from it as a result. So the delay on the application will grow. What's good about this solution is, as we keep the PDU session anchor, the originally allocated IP address for the UE is preserved. Of course, this remark only makes sense for the IP type of sessions. I will return to that, the significance of that in a moment. Then, session and service continuity mode 3. What will the network do? It will release the existing PDU session, and it will ask the UE to start a new PDU session to the same data network. But over here, the new PDU session can have a new UPF acting as a PDU session anchor. So in that case, this is very often called break before make. You release the old session, you create a new one with a new PDU session anchor. This, of course, implies session interruption. For a certain time period, there is no data transfer possible, which means live applications would not be happy here. And side effect, technologically speaking, if you use either this UPF or sometime later a different UPF as a PDU session anchor, it means that for at this moment in time, IP address used for this UE goes through here. Sometime later, the same UE IP address, you can have routing point to somewhere else. So with SSC mode 2, you can keep the IP address of the UE untouched. Same as here. Why am I underlining that? Because there is a lot of applications that cannot handle change of the IP address while the UE is using the transport network. So if you change the IP address, a lot of the applications go bust. The main reason for that actually is that in the current systems before 5G, we didn't really have a mechanism from the system itself to inform the application that an IP address has changed. While if you look down here, SSC mode 3, there is a remark. In this case, the IP address of a UE will change. If we use this method of following the movements of a UE, unfortunately, the guaranteed side effect is that the IP address will change. And why does this happen? Because in SSC mode 3, the network allows the establishment through a new PDU session anchor before removing the old PDU session anchor, which means for a certain time period, I'm going to have 2 parallel data streams to 2 different PDU session anchors, the previous one and the one that we change into. But you cannot have both of them work on the same IP address of the UE. There is the old IP address of the UE and the new IP address of the UE that points to here or to here. So the consequence of using SSC mode 3 is that the IP address of the UE will change. And then we have to handle somehow the fact that an application might have a problem with that. The best way of handling this would be to have a report from the 5G core network, where IP addresses are handled, into the customer's application function. And I will show you later that this can be done through this. Do you maybe remember the NEF, network exposure function, this kind of border security entity through which all information to or from an external customer is going before reaching the 5G core. We can use this communication path to inform the customer of an IP address change. So when we talk about the network exposure function, I'll talk more about this later on. Now, how does the SSC mode 3 work? It says over here that we will establish connectivity through a new PDU session anchor. This would be make a new session, and after that remove the old PDU session anchor, which is break. This one is called break before make equals session interruption time. This one is called make before break equals no session interruption time, but IP address change. And then depending on what kind of application we have, you can decide which of these is best for this particular application. And this decision is taken at the PDU session establishment, it's decided in the application in the UE, and is communicated to the network during PDU session setup if the application in the UE is smart enough to do it. Now, if the application in the UE is not smart enough to do it, the alternative is to store the behavior in the subscription data in the UDR. And then, as you maybe remember, when we said that when you start a PDU session, we saw these arrows for PDU session establishment. Part of that picture was that the session management function downloads subscription data from the UDR. In the UDR, you can store that for this and this data network name, such and such SSC mode is the default. So the network will know how to treat it. And just to illustrate these three nodes, slide number 4, I have my UE over here, over the radio access network, but I'm more interested in this part. SSC mode 1. Originally, we choose a PDU session anchor. It will be maintained throughout the session and the IP address is preserved. End of story, basically. What can happen is you can add another PDU session anchor over here, but this one has to stay in the picture. And these additional PDU session anchors, they can be added and removed. But this is like the master, it has to stay over here. Now, this remark, because what appeared over here is splitting, is what I would like to refer to now, and we will do it properly later on. If you want to add a new PDU session anchor, like in my picture over here, then the session management function responsible for this UPF has to give it, well, the two alternative options, which packets go that way and which packets go that way. This is called either uplink classifier or branching point, and I will have to talk about that later on. This is how to do splitting. We'll come back to that. Then on slide number 5, SSC mode 2, as I said, this is break before make. So as we said, the network will trigger the release of the original session. To be more precise, we want to get rid of this one. And we will establish a new session to the same data network. So first you remove this part, and then you create a new path going to the same data network over here. And same as previously, let's not forget that for this PDU session, at any moment in time, we can add a new PDU session anchor or remove it. This statement still holds. And then SSC mode 3, make before break. This is my original session, and the session management function starts by adding yet another PDU session anchor over here. So there is a moment in time where these two work in parallel, and if there is data transfer, there are two possible data streams. Some things might have still be buffered on the original path, and some new data might be coming from here. So there is also a question of rearranging the information in this UPF over here that does the splitting. But as our purpose was to remove this one, then after the new path was created, we will remove what was over here. Plus the same remark as previously, at any moment in time we can add or remove other PDO session anchors. They are kind of on the side of the picture that I'm basically talking about over here. So, why did I start talking about the session and service continuity modes? Let me return to the origin of that remark. We are writing in here, why might a session management function decide to have more than one PDO session anchor for a session? And the third reason for that is, if you want to use make before break, then you need to have the splitting and you need to have the two simultaneous outgoing connections to two different PDO session anchors. So if you want to have SSC mode 3, you must have PDO sessions with multiple PDO session anchors. This is a tool for that. The other two SSC modes, 1 and 2, don't need splitting, because in the other two cases, I only have one connection at a given moment in time. In the first case, it's even completely stationary, basically. So, this is the reason why we might want to have PDO sessions with multiple PDO session anchors. That's the purpose of that procedure. The next question is, how do we know that this should happen? How do you know that for this particular application going to this data network, we needed to do the splitting over here? And to be honest, I'm switching over to blue color because I want this to stick out. The reason to do the user plane splitting is because the customer wants it. So I'm using blue color over here to talk about something that is called influencing, traffic influencing. Influencing, where does it come from? From the application function in the customer's network, in the customer's site. And this application function, well, I want the information to reach the session management function to do the correct thing over here. And the only thing is, this is the moment when the operators start panicking. Whenever I draw lines like that, they say, are you telling me that the water company can insert data into my session management function? Forget about it. Of course, forget about it. The principle here is to go through this part that is going to protect us from unauthorized access, or even quite simply from stupid settings. So what is placed as an option in the standards, but all the operators are looking at doing things that way, is the fact that the application function through the network exposure function will send its information into the system. This is external influencing. So we are using the network exposure function to manage routing of a particular PDO session. And this information can be about establishment of a session with multiple PDO session anchors, or change of the PDU session anchors at any moment in time later on. This is an external choice. And now let me add over here name of a very important interface. I wrote in the text that this influencing goes via N33 interface. N33 is an interface between the application function and the network exposure function. This is what I mentioned yesterday. These are so-called northbound APIs. Which means in the standards they have defined what is the format of the incoming information so that the network exposure function can then send out the relevant parts of the incoming data to the correct network functions. And please notice what is marked. This is the service bus. Of all the network functions on this service bus, we can see over here the policy control function mentioned, because I wanted to underline that whatever comes from the application function over here, it can be pushed into the policy control function, and the policy control function is what the SMF talks to at session establishment. So this can be source of that data. Now, this part of the picture, N33 interface, external influencing, just so that you know, once again, don't do what I'm doing now. I just want to show you something. I will have a foldout which will concentrate on the network exposure function, what information can be pushed into the different 5G core elements, what can you provide to the customer in the answer, like the IP address change. This is a big topic in itself, so we will talk about that separately. So, of course, if you have any questions about what I put up on the foldout here, you're welcome to ask them. But I just want you to be aware that this small remark, what goes through the NEF, we are going to elaborate on later on. So, what did we say? 1, that a PDU session can be split into a number of branches. 2, that the order to do that comes from the session management function based on external information. 3, the reason that why would we want to do that is one of these over here, right? So what I'm left with is to see how can we do that. What appeared on this presentation, uplink classifier or branching point. These are two technical solutions. How can we do the splitting?
Can I have a question?
Sure, of course.
In the branch, every branch we will have a different IP address for the UE?
No.
No.
One.
Okay. One.
Okay, so 2 technical solutions. I will return to your question. It will become clearer in a moment. What appeared on a presentation earlier on was something that it was this abbreviation, uplink classifier. Uplink classifier. This technical solution bases, excuse me for a moment, on the fact that when the session management function is informed of the need to do the branching, the session management function, in the order to the UPF that is supposed to do the splitting, will send this information to the responsible UPF. So I'm adding over here that this UPF has an uplink classifier from the session management function. And it sounds like a very advanced thing, but what it blends down to is that the SMF, that's what they say in the standards, installs the uplink classifier in the UPF, and then this UPF performs classification of a packet based on what was in this uplink classifier. And then UPF performs routing, or does the forwarding if you prefer, based on routing rules. And this means that for the UPF, it will look at the addresses, source and destination address. And when you say that you look at addresses, it can be either IP addresses or MAC addresses, depending whether we are talking about an IP session or whether we are talking about an Ethernet session. And then, this is kind of always used. Optionally, classification can be on origination and destination port number. Maybe we can put a remark over here, but also port numbers. And this one is very interesting. I would say that I see it as absolutely normal that the SMF tells the UPF, if you see an incoming packet with this and this addressing information, including the port number or not, forward it in that direction. This is absolutely clear for me. But this is very interesting because it means that the session management function can ask the UPF to base its routing decision not on addressing information, but on the quality of service values of the data stream that has been established. This is, of course, connected somewhere in the UPF to a packet filter with the addresses, but the actual order from the session management function can be descriptive. It doesn't have to be the actual addresses. We'll see how this develops. This is quite new things in the Release 16 standards, but they open up for a much bigger flexibility in the system. So we'll see where this takes us. So that's the uplink classifier possibility. And then the other abbreviation that appeared on the presentation earlier on looked like British Petroleum branching point. And in this case, the source again is the SMF. So the session management function installs the branching point in the UPF. So we can add, I'll just move over here for a moment. We can add that this UPF receives either the uplink classifier or the branching point in order to know how to do the splitting. And going back to these remarks here, what is implicit, but maybe you've noticed, uplink classifier can use IP addresses, which means you can do splitting for IP sessions. Uplink classifier can use MAC addresses, which means you can do splitting for Ethernet sessions. We cannot do splitting for unstructured because we don't have any addressing information to work with. Maybe in the future we can base it on quality of service values, but it's not in the standards yet. While in case of a branching point, I will now make a statement. This will only work for IPv6. It's only an IPv6 feature, which seems very limiting, but if you think about it, we honestly expect that most of the traffic that we will see over the 5G networks will be IPv6. And the reason for that is because the branching point is in effect using a native IPv6 feature, which is multi-homing, which means one UE is using two different IPv6 prefixes. And now I'm going back to the question that popped up a moment ago. I'm sorry, I don't remember who asked it. The question was, does a UE have only one IP address? The question was for these different branches, right? And then I said yes. My answer was true. But let me point out to you that there is a moment in time in the system where we might have different IP addresses for a UE. And this would be when we are using the IPv6 branching point with the IPv6 multi-homing. In this case, the same UE can have two different IPv6 prefixes, meaning two different IPv6 addresses. Does my answer make sense now?
Yes, thank you.
You are welcome. There is an I missing from multi-ho or an L. Can you please add the L here yourselves? Because the tool that I'm using, it was designed in such a way that I cannot do what you cannot do, which means I can't just, I would have to delete everything. It should say multi-homing. Thanks, of course. By the way, it's good to know that you guys are out there. It's always more fun than just talking to the camera. So thank you. So this is the two technical solutions, either an uplink classifier or a branching point. And then the bottom line over here is to remember that with these different branches, we have different N6 interfaces, and each of these N6 interface terminates in a PDU session anchor. I know that we've already said this a few times, but let me just put it here clearly. A PDU session anchor is this UPF that terminates the N6 interface. This is a common abbreviation for interface. I use it to avoid the writing more than absolutely necessary. So we have defined, in my mind at least, we have defined this splitting part over here. And by defined, I mean we said, what is it for? We said, what does it look like? We said, how do we know that it needs to be done? And then we have seen what technique can we use in order to have splitting performed. I am done with this part of the foldout. Are we good? Because I want to move over to the second remark over here, which actually kept coming in while I was talking. It was about changing things. So now I would like to say just a few remarks about relocating, because we've mentioned it quite a bit, but I was just waving my hands, and as I say, I prefer to have notes. So it's possible for a session management function to decide during the lifetime of a PDU session to either add a new PDU session anchor or to add and remove the old one, which would we could interpret it as changing the PDU session anchor. And please notice, I'm talking about the PDU session anchor here, but I also wrote that, of course, the session management function can also change the other UPFs that are somewhere in the chain. But this one is the most important, the one that terminates the N6 interface. And why would you decide to do that? Why would you decide to do this change? Well, the first option is local for the operator, and it's done on the user plane. The user plane functions responsible for traffic detection can see that, I don't know, I'm overworked. I want to move the responsibility to another UPF which was instantiated with a bigger capacity, for example. So the data stream is getting too big for me. I want to move it elsewhere. So this is like a local operator's load redistribution for the particular traffic where the data stream has grown since the beginning of a session. So this would be one reason for it. Another reason would be when the access and mobility management function detects that the UI or is informed changes the access network that it is using. Or I don't like the word location because it's very imprecise, but I just wrote over here that the AMF might detect change of UI location, whatever that means, and as a result might want to change the PDU session anchor. Location can mean latitude and longitude. It can be from triangulation. It can be the cell that the UI is using. It can be tracking area. The word location is can mean different things. But basically, the AMF, when informed of one of these things, it might trigger, if the session management function asked for such reports, it might trigger a report to the SMF saying, hey, we have changes here. Maybe you should react to these changes. And I'm going to make something over here. I will use blue color. But I would like to add one more bullet point later on. But what's the AMF doing? And this last bullet point, I want to have them all together under one comment. Because it's one thing that the AMF detects changes, it informs the SMF. But the other thing is, but why these changes should result in that changes. And this is usually what the customer asks us to do. So I'm going to put over here a remark that in majority of these cases, this is probably triggered by decisions from the application function over the N33 interface. So the customer wants us to follow the UI. This gets detected in the AMF. Because of that and that information, the SMF makes the decision. And another thing that can come from the outside that will trigger possibly change of PDU session anchor can be an explicit order to activate a certain type of service as yet another branch in an existing PDU session. For example, the application function might want to start the edge computing data stream. It might want to activate MEC. So I will write over here, one more reason would be to request edge computing. And that's about the relocations. Now, just so that you know, as this is an overview course, and I said we will start from scratch, and I will try to tell you as much as possible within the time we have, there are moments when I need to say, now I'm done with the topic and I will move on. But as you might guess, everything that I'm presenting to you here means that the next step of information is to understand, from my perspective, understand the signaling flows, see how we do network monitoring, because all of these have impact on how the network works. These are products that all the operators are interested in. All the operators are interested in sessions with multiple PDU session anchors because they're interested in edge computing, and all of them are interested in possibility of relocating the PDU session anchor to follow with edge computing for mobile devices, because the operators see this as an earning service. They think they can monetize that. So there is quite a lot of interest in these particular things. But as I said, I am time constrained. I could talk about that for another day probably, but I'm going to back off here and I'm going to say I'm done with this fold-out. So if you want more information, if you want me to start you with where to find more information, I'm going to make a break now, 12 minutes long. And if anybody wants to talk to me, please do it. Okay. So, as I said, I'm going to move over to the next topic. Well, I would like to ask you to open up the next foldout, but we will actually do the foldout itself. Majority of this information will come tomorrow. I just want to get us started in the understanding of what the network slicing is. And then again, we will talk about what is it for, how can we realize that certain identifiers and methodology from the technological perspective of realizing network slicing. But first, if I just look here underneath the title, the first question is, what is it for? So let's maybe start here. I used the term logical networks earlier on to describe a network slice. So you can see here, network slicing, we will create different logical networks that have different characteristics on a particular physical infrastructure of an operators. And the reason to do that can be because the applications from particular users of the mobile network can have very different traffic characteristics. So we might want to have a logical network that fits what this application needs. For example, I keep talking about reliability and delay as the critical parameters, because as you probably know, the parameters connected to throughput, we are already quite okay with LTE, but reliability and delay, we need some more tools that the LTE doesn't really have. Next, you can have coverage for different types of services in different locations, in different places. We might need to basically think of how to dimension, how to place the equipment. And then network slicing is also a useful tool, how to divide these physical resources between different users, and also for different UE registrations coming from different areas. We might want to have basically, this is pretty much about the scalability, about having the physical resources in the right places and then allocating these resources in correct bunches, if I might call them that, to particular groups of users. So I think for me the key word over here is, the key term is network slice is a logical network. And by the way, when you think about it, a logical network, we already have such a concept for many years now. You might have heard this concept of MVNO, mobile virtual network operators, where the infrastructure belongs to one company, but then a virtual operator runs on top of that, but it presents itself on the marketing level, mobile country code, mobile network code services as a separate entity, as a separate offer to the customers. If you think about it, with network slicing, if we look at virtual operator as a logical network overlaid on a physical network, this is what network slicing will be very good for. So basically, the direction in which the standards are heading, the idea would be ultimately that a mobile operator in their war zone, as I call them, where you have the operation and maintenance center with all these huge displays, what's happening in the network, they will have in their OSS system a button which says start a new MVNO. And after pressing this button, automatically certain things are going to happen with some default parameter settings, and 5 minutes later you have started a new virtual operator. That's one button that we might want to have, which network slicing can be used to realize. Another button, I also mentioned the term private networks, where you can offer to, if you're a mobile operator, you can start talking with a particular big company, for example, Ericsson, and you can tell Ericsson, listen, we are going to give you a private network isolated from all the other companies. Your data, both the one that is traveling and subscription information, will be secure. It is just simply your part of a network where nobody else is using it. And from a perspective of Ericsson, it would be fantastic to have an Ericsson network slice over, well, mobile operators basically in the whole world, because Ericsson has offices everywhere. I remember how painful it was back in 97 or 98. I was on a bigger project with Ericsson in Turkey, and I was trying to get my remote access to the Ericsson network on the private networking that Ericsson had. So if we could have this network slice worldwide, it would be absolutely perfect for huge customers. When I say customer, I mean from the perspective of a mobile operator. And this brings in one more thing, network slicing versus roaming. Because if you want to have your Ericsson network slice worldwide, it would mean that Polkomtel in Poland and Vodafone in Germany and Orange in France, whomever is chosen as the deliverer in a certain area, they would have to have the same network slice definitions that fit the traffic pattern of, for example, Ericsson as a company, so always in the old times memos and emails and Zoom meetings and so on. So these buttons are very interesting, but of course to have a button to press, there are things hidden behind it. We need to have templates, we need to have some definitions. I will want to talk about all of that, of course. But before we go into the technology, which I will talk about tomorrow when we are a bit fresher, I would first like to talk a little bit more about these types of networks depending on the traffic characteristics. So not virtual operators, not private networks, but just based on the requirements of particular applications. And in order to do that, I will actually refer to something we have introduced earlier on, but now I would like to elaborate on it. We are in chapter 5 now, and if you please look into your slides if you want to. In chapter 5, slide number 2, do you remember this triangle where I said that we have 3 use cases defined by ITU and then used in documentation throughout the industry? There was mobile broadband, IoT, and the orgs. So let's start with the enhanced mobile broadband. Why? This represents the triangle we saw earlier on. And this slide over here, slide number 3, actually the information here is very old. You can see here the source is a survey that was performed back in 2016. So dinosaurs were still alive when we look at our technologies. But the outcome of the survey was very interesting. The GSM Association asked a question to different CEOs in the big players in the industry. And the question was, if you deploy 5G in your network, if you're a mobile operator, why would you do that? What is your highest priority use case? Where do you see the money? How do you explain the cost of starting a 5G network? And 74% of the responders, I think there was under 100 people that were questioned here. If I remember correctly, there were 21 questions, it's just one of them. 74% of the responders answered the reason to have 5G is because they want to have enhanced mobile broadband. So this network slice is most important for them, to have ultra-fast internet, to have enhanced video, augmented reality, virtual reality, and work and play in the cloud, because this is where the operators saw that the money is sitting, the easy money is sitting. And this basically means improving on what the LTE can do, have higher throughputs, lower latency, lower delay. This was the start. Then a surprisingly big number of operators, because we can treat their CEOs as a representative of the operator, answered, 1 in 5, we want to have 5G because of the Internet of Things devices. The reason for that was twofold. Reason number 1 was that back then, over the LTE network, a lot of operators were already using or offering services to more and more customers from the Internet of Things. And suddenly, the operators realized that they have a problem with the number of devices that get attached. I don't mean here the traffic necessarily, because if it's a water meter, it doesn't say very much. Air pollution sensor, this is not a lot of data. It wasn't really a problem of dimensioning the user plane so much as the fact that every single water meter has its own subscription in the central database. If you suddenly have millions of them, you need to have the storage space for their subscription. But the money that you're making on that is very small, because how much can you charge for 15 octets from the water meter, even if there is hundreds of thousands of them? So it suddenly became a money problem. That was one thing. And the other thing is that they've realized very early on that we can have a new group of customers. I keep talking about this 5G in the box, in a hospital, in the smart factories. These different vertical industries, suddenly this is a possibility of making money. Another big one over here is cars, automotive industry, communication between automatically driven cars, the collision avoidance, things like that. So 1 out of 5 CEOs saw that this is a business opportunity. And then just a few of them saw, okay, dedicated services, advanced augmented reality and virtual reality, mission critical, industrial and vehicle automation, the one that requires it to be orcs. They say this is a lot of work on the network. It's going to cause a lot of problems, and there is not very much money in it at the moment. So very few of them said that the orcs are the reason to deploy 5G, which means if we look at the features in the 5G network, most of the new features address enhanced mobile broadband and the massive IoT problems. While how to handle the orcs, this is still very much work in progress in the standards, just so that you know. And of these 3 possibilities, I'm going to start with this one because it's the most common in terms of the answer. So we are going to start over here. Just to remind you, these were the pictures for enhanced mobile broadband. So it's people, it's connecting the whole things. This is from the 5G PPP, and these were the types of services that would like to use enhanced mobile broadband. With one remark that I've made, the voice service also belongs here. So if an operator wants to have voice over 5G, they need to have the EMBB network slice. Now, what does the enhanced mobile broadband network slice address? You remember these were the requirements from the 5G PPP, and we said that if you increase the throughput for a big number of users that are people, then this is where the mobile broadband is going to be good. Now, if you look at the title, this is slide number 7. What services can enhanced mobile broadband work with? What are the applications that we can put into here? And probably what is on the slide was the reason why so many CEOs answered, this is where we want to start, because there is such a huge possible usage of these network slices. Classic mobile broadband, this is basically improving on what LTE can do. And as I said, you can read the things on your own, you don't need me for that. But this is basically whatever LTE does, but quicker, better, with better coverage. Placing voice over 5G. Do we keep our VoLTE solution, voice over LTE, or will we move voice over to 5G? This is a very big business case, especially this one, the fixed wireless access. Basically, with this 5G technology, we could have broadband internet delivered to areas where no other access to internet exists. So fixed wireless access is what is for smaller places with lack of internet coverage. High definition media streaming. And here what comes in here is caching the content closer to the UE, so the edge computing comes into play. Localized services, local area data networks. I promised to talk about this and that on a separate fold out, and we will do this. And more and more and more. So this is the the scope of what the EMBB can basically cover. And then what the operator is going to do, you can look at slide number 8 over here. What is here on the yellow backdrop is the mobile operator's equipment that fulfills the needs of UEs that want to use mobile broadband. So this part over here, this column, these are requirements on the network. We have to be aware that these are mainly smartphones. There is a certain number of them per kilometer square. They need a certain total capacity. There will be high peak rates at certain moments in time, and they will be mobile, with the exception of the fixed wireless access, where the endpoint for the 5G radio is stationary, and then it beams out the internet in a certain area. So these are the requirements. And then these requirements will feed into how should we set up the radio network to fulfill them. So here you have a list of features for the radio access network, and how should we prepare our core network. So what does the slice of the core network resource look like? Now, for these descriptions down here, I think this part will be kind of easier to understand because we started with the overview of the core network. We talked about that a little bit. So you can recognize over here, if we want to have EMBB network slice, we need to have UPFs with high capacity and a high capacity transport network. We want to be able to use multiple PDU session anchors. We want to use edge computing. This would be expected in the EMBB network slice from the core network. While if you look at the services expected from the radio access network, well, here it's a bit more tricky for me at this point in time because we didn't talk about the radio network. So you can return to that later on after we've done the NG run, but basically it says here we want to have coverage everywhere because EMBB is supposed to have coverage everywhere. We will have for that macro cells, but macro cells usually don't have very high throughputs. To increase the throughputs, some small cells with extra frequencies. We will have dual connectivity and similar feature carrier aggregation. This is about giving more throughputs to a particular user. Massive multiple input, multiple output antennas, which means, again, throughput increase. We'll talk about this later on. And building beams over the radio that are targeted at a particular user or particular region. This is a typical 5G radio feature. It didn't exist earlier on. Tight interworking with LTE, we already know that. We have a G node B and an E node B here to use the existing infrastructure and its capacity to combine it within the 5G NG run. Use of unlicensed spectrum, obviously, to help us with even more traffic to be sent out, and aggregation with Wi-Fi, which we also talked about. So as you can see, the impulse very much here is to have the word broadband defines what we would like to see over here. Now, just to explain everything, of course, the green lines going here are the user plane data. And you can see that here we're going to internet. This one is going into IMS. I will return to that in a moment, but we've mentioned already IMS is the control plane, control platform for voice over 5G user plane connection. So we need that to have voice over 5G. And over here you can see that this EMBB network slice, here there is a number 1. This is so-called slice service type. We'll talk about this later on. I will write it up. But for now, I'm just trying to point out that there is a default defined in the standards value, which will help you identify that I want to use such a type of a network. But apart from that, we also said that we might want to have other types of customers, virtual operators, private networks for corporate customers, maybe some kind of premium set where you give a platinum subscription to someone, they pay more, but you guarantee something more for them. So please notice that here on this green backdrop, I have another EMBB network slice. It's still mobile broadband, so it's still this number 1 here as slice service type, but you can see that they differ with some other identifier over here. This is slice type 1, number X, and this is slice also type 1, but number Y. I will return to that. We will talk about that later on. And then the green path going over here can be different quality of service, different priority, isolated from the other resources or whatever the operator wants to offer. This was the EMBB network slice, but I pointed out that voice uses EMBB, and we mentioned the IMS. So I would just like to show you, this is slide number 9. I would just like to show you a little bit about voice over 5G. And this was actually my reason why one of the reasons why I was asking you, do you know anything about LTE? Interestingly, the answers you gave me were no, mainly. But then suddenly when somebody started talking about the MTAS in the chat, well, so at least this part over here, some of you are familiar with. So just to put it into context, IP multimedia subsystem is the control plane for the telephony service. It's been around since 2008. It controls the access network. In this example here, it's the evolved packet system, so it's 4G, over which network we can have resources that are configured to send signaling into IMS. So this would be call setup signaling, for example, call modification, call release, and different resources that are needed for the actual voice calls. So this is the RTP stream over here. These are called EPS bearers, and this connection into IMS is called a PDM connection. Some of you might know it if you've worked with IMS. We can also have Wi-Fi calling, as I said, so there is an access point over here, the gateway for Wi-Fi, authentication, authorization, and accounting server dedicated for Wi-Fi, but this is plugged in to the regular 4G core. Now, if I move over to voice over 5G, the EMBB slice will carry voice over 5G. You can see my UE, my G-Node-B, a number of these network functions from the 5G core and the UPFs, which are on the user plane. They're not network functions, they are routers or switches. And here, we used to talk about packet data networks in 4G. In 5G, we say that you will give a connection to a data network. This connection is called a PDU session. And within this PDU session, I need exactly the same things that I needed earlier. So I need to have resources that can carry the call setup signaling. And this means that I will have, I heard a bing, I'll have a look in a moment. This means that I will have a quality of service flow that corresponds to what was called the default EPS bearer in 4G, that will allow me to send the SIP signaling into the good old IMS. And I need resources, it's also called the quality of service flow, but this corresponds to the dedicated bearer onto which I can put the RTP data that will also go through the IMS to whoever is on the other side of the connection. And you can also have, just like here you had the access point with the Wi-Fi, this is also true for the 5G case, Wi-Fi calling. It's just that the gateway changed a name to the non-3GPP interworking function. I'll just have a look at what's binging over here. I mentioned MTAS, but I'm not familiar with it. We're making a generic component, and MTAS is just one of users. Okay, clear, thank you very much. But just to put it into context, that this is basically the same environment that was there for the 4G case. So this would be voice over 5G environment. And then the second group of CEOs said, we will want to deploy 5G,
because we want to work with the IoT devices better. So starting with slide number 10, the second use case of 5G system, massive machine type communication or massive IoT, both of these exist in the standards. And if we now look at this one over here, the 21% that answered, that's what we said. It is basically about smart cities, smart buildings, and so on. This is what machine type communication is for. And when we look at this famous triangle, what goes into here? Smart city, smart home, smart building. We don't put hospitals over here because they are more of an org. And what does this slice work with? With the fact that we have to connect so many devices. So here we will have features for power saving mode, which I've mentioned already, to save on the device's battery. Here we will somehow optimize the amount of data that needs to be stored. Here we will have dedicated tools to do batch processing, so that we no longer have a signaling procedure for one device, but we will have one signaling procedure possible for a number of devices that belong to the same application. So all this falls into the IoT network slice. And by the way, just to show you the scale of the problem, forecasts. So forecasts might be right or wrong. We are talking here about wide area networks. Mobile operators will use 5G to give wide area solutions. So it's just 30% of the needs of this industry. But if you just look at that, what is in our domain, if you look over here, expected in 2030, this is based on what is in what was in 2020, measured earlier on in this year. Expected in 2030 is that machine type communication will give 12% of the total traffic, which is not scary, but look here. 85% of the subscriptions are expected to be from the world of IoT. Look at the number. This is what has to be somehow handled in the 5G network, smarter than with the tools that the operators got in 4G. Now, this slide number 15, I won't talk about it. I just wanted to show you an illustration. And by the way, it's just a selection. Who is interested in definitions for IoT? There is a lot of players over here. So there is a lot of different forces pushing for things to happen. The IoT definitions are very volatile. There is a lot of things happening over there. Now, if we look from the 5G perspective, what can we do with serving the IoT devices? Smart cities, sign an agreement if you're a mobile operator with the city, like the city of Brussels, for example. Transportation information, just let's remember that this is for the non-orgs. So it deals with transportation, but unfortunately the delays are so big here that this is not for automated driving. But traffic and fleet management, logistics, traffic navigation tools, all of this is IoT. Again, the non-orgish healthcare, like patient monitoring, it can be wearables. Like my father has diabetes, and he could have a band which measures the level of sugar. You can now do it from the skin and reports it to his answering center. For this information, it doesn't have to be extra low latency system. If the information takes 1 second to reach the hospital, it's fine. It doesn't have to be 4 milliseconds. Home, I'm getting more and more things like that in my own home. I have a cooling system in Krakow, where I come from, which is remotely controlled. Here in the village house, we are just installing photovoltaic panels this week, and I will be able to monitor from Krakow what they are doing, and so on and so on. Retail services, obviously. Security, surveillance, like a camera in a shop that just sends stills to somewhere every 30 seconds to a central server, but then maybe when it detects some movement which shouldn't happen, it switches over to a constant video which can later on be used in court, and it can call police or whatever. So These can be a bit tricky because they can change the profile of the traffic that they are using. Monitoring of energy. The industry, once again, I mentioned factories, but these have to be the non-orgs. The orgs need URLLC network slice. And personal. A lot of money potentially sitting here if only we can monetize the mobile networks into some devices that send only a little bit of data. In order for the operator to make money here, they have to ensure that their network is cheap when they buy it and cheap to run. And for that, cheap when they buy it, everybody wants virtualization, and cheap to run, everybody wants something called MANO, management and orchestration, automated way of monitoring, controlling, and handling what's happening in the network. Now, I just wanted to show you that you have a slide, this is number 17, so that we are aware that when we talk about the world of IoT, it's really not going to be uniform because different IoT devices have completely different traffic patterns. A fleet tracking device service or an object tracking is completely different from the water meter and gas meter. So please notice what I'm saying is, until now I keep talking about an IoT network slice as though it were one. But on this level, we can see that I would actually expect one operator to run a number of network slices. A network slice for stationary devices that only send a little bit of reporting, a different network slice for broadband, like surveillance cameras, and so on and so on. Now, the considerations for the IoT devices that the operators have, I've mentioned some of them, so I just wanted to have this slide, it's number 18 in the course, but you can read it on your own. What are the operators looking at? How to handle all these devices, how to do the low power consumption, how to do small data transmission. Maybe we don't have to establish a whole user plane, maybe they don't need IP addresses, how to deal with the fact that water meters are in cellars, how do we extend coverage, how do we make sure that we neither have to change the battery too often, nor that we have to change the SIM card if the coverage is wrong. So that's one thing. The devices are supposed to be cheap. What if they are not reachable? Remember that? If they cannot be paged from the network, how do we handle that? Can we use multicast on the downlink? And how do we make money on that? So you can read through that if you're interested in this part. But what I would like us to have a look at, this is slide number 20. You can see here that on this backdrop, it says massive machine type communication network slice. You can see the default value for a massive IoT in the standards obviously is 3, and this is 3x. This is a network slice that is good for my water meter. And same as previously, these are the requirements. So we have to be prepared for a huge number of devices that are very simple, but want to use power saving, but want to be in mobile initiated connection only mode. You should have all the abbreviations here, which means it's unreachable most of its life. It only talks when it wants to. Maybe the UE should deregister after communication. They send little data at low rates and it's non-real time. They sit in place, they're stationary, and some of them might have just one gateway, like in a block of flats. You could have one, let's call it SIM card here, with a number of devices hidden behind it. This would be the short range local area network. And for that, we have other technologies like Zigbee, for example, is quite often mentioned. So these are my requirements that feed into the operator's decision how to build the radio network and what should the core network fulfill. And again, starting with the core network, a big number of registered UEs, so I want to have batch processing, I need to have the storage dimensioned properly. The user plane capacity is not a concern, and we would like to get information. Do you see here this information path we would like to have information from the application function that sits in the utility company, pushed into our 5G core network, and then forwarded also to the access network. What is the expected UE behavior, which means how much, how often will the device send or receive, and the device's mobility pattern. How is it expected to move if it's not stationary? So a mobility pattern in this example can simply say the devices are all stationary. Switch off the mobility handling, which would make this network slice cheaper. Certain things that it doesn't have to do. For the radio network, once again, I will return to the radio network later on, but you can see over here, coverage everywhere, low power, wide area network. Should we use the existing 4G solutions, that's narrowband IoT or LTE for machines, or should we use 5G? And there are certain features to help us with handling IoT devices. And we must be prepared that most of the time the radio network doesn't know exactly where the UE is when we talk about paging. But we'll talk about the radio network later on. So that's a utility meter example. But if we talk about IoT, we saw that there are so many different applications with very different needs. So another example, object tracking. These can be lions. This is network slice. It's still number 3 here, but this slice specific part is different. So I can have my lions over here, or reindeers if you talk about north of Sweden. We don't know how many there are. They are low complexity. They send little data at low rates. They infrequently report, and maybe only upon request. But what is characteristic for them is that they can move really fast. Lions or reindeers do move quite fast. With this input, core network, what about the user plane capacity? Well, if it's low data, then the same remark as previously. We want to get expected behavior and mobility pattern from the user, and then maybe we don't have here this session we have over here. Maybe we will not keep the data radio bearers and the N3 tunnels all the time, or maybe we won't even establish them at all. Maybe we could use more of an SMS type of service where the information is put into signaling messages without setting up the user plane completely. And if you look at the radio network, well, this is pretty similar to what we saw earlier on. You can read through that if you want to. You can check for more information if you feel like it. And then the last one, which are the orcs. This is slide number 22. Ultra reliable and low latency communication. And before I move any further, let me just make one remark, because I've seen people mistake this very often. This use case contains 3 different kinds of applications. 1, applications that need ultra-reliable transport. 2, applications that need low latency. And 3, applications that need both this and that. And of course, these are the most difficult ones to satisfy, to have a network that can serve them. So we are down here. Only 5% of the operators said that it's worth their investment initially, at least. This ultra reliable and low latency communication, we are talking about the e-health, we are talking about smart mobility and car-to-car communication. And on this triangle, these were augmented reality, industry automation, self-driving cars, mission-critical applications. These are the verticals that will probably want to use the service. What does this network slice address? The requirement that we want to have perceived zero downtime and latency close to zero. And if you look over here, ultra-reliable and low latency communication, just so that you know, operators would like to have 5G in the box for factories, for hospitals. They see there is money in that. They want to cooperate with the industry where you have BMW, Mercedes, Audi. They have quite a lot of money. And what the operators are not so keen on, but will be forced into doing probably, is the governments have a tendency of forcing some public safety solutions to be offered by the operator. So the operators have to be prepared for requirements that come from the legal, not from the technical or the monetary side, to deploy the ORC network slice in their network. They might be forced into that at some point. And just a small remark that the automotive industry over here, there are already solutions. They are in Japan slightly different and in Europe slightly different for this cooperation, for this communication over here. You can see the frequencies on which it goes. I'm just going to see what this ping was about. Military, yes. Yes, I mean, it's hard to say what is going to happen, but because the distinction I'm trying to do here is that part of the setup of a network is business driven, but part of the setup can be driven by external influence, and this is legal matters. And the question is whether you want to see military as a customer for whom you do dedicated services, and I know such solutions, or is it something that is forced upon the operator from the law of a particular government? So it can be quite different in Finland than in China, obviously. Again, just where do we think that 5G can help when it comes to this URLLC network slice? Industry, automation, the utility sector, healthcare, vehicle to whatever, and mission critical services. I wanted to have us here if you want to read through that later on. It's quite straightforward, or you can search it on the internet, but it's a good collection to have, I think. And for the orgs, again, consideration, big number of devices, some of them may demand very high bandwidths. We might have the need to deploy small RAN sites in a certain industrial site. The devices might not be reachable, and communication between different operators and the radio access types. The key thing here is when you have cars moving between countries, when we have roaming issues come in, which I've already mentioned that roaming is a bit problematic. It's just that I used Ericsson as an example, not the automotive industry. There might be incomplete coverage, hard access to some devices. We need to have security on an appropriate level, how to implement ultra reliable and how to make money on it. So these are slides which are more like, if you have time, then you can read through them on your own. But as I say, I'm rather focusing on these slides over here, where we have okay, an example, a hospital, requirements, and then the impact on the network. You can see here a hospital example. These are patients that are lying in beds. These are patients that are slowly shuffling along the corridor. So it's stationary or limited mobility, and no number per square kilometers. And these are mainly meters, sensors, and actuators is something that you get an impulse from the network for a physical device to do something. For example, if my father had an insulin pump, when the low sugar level is reported, he can have a small syringe for good. And if he's unconscious, there could be an impulse to put in some of the medicine that he needs. So this is the input. Core network. Maybe we would like to have a local area data network, localized service, and UPF co-located with the radio network. Do you see this? A UPF co-located with a G-Node B with a hospital server over here. What does this give me? This is edge computing if I've ever seen it. This gives me the low delays. Plus the need on the radio as such, reliable radio, packet duplication. Again, this is radio specific, but it's for reliability and low latency. This was patients in a hospital. Now, this is a not very quickly moving traffic jam, vehicle to whatever. We have a number of cars over here that send little data at low rates. They are fully mobile. They can go, okay, a car that goes to 500 kilometers per hour. This is more for helicopters and small airplanes. As I told you, 5G will move into the third dimension. So, and we need to have a direct communication between the devices. And these requirements feed into the fact that we might want to use edge computing. We want to have UE behavior and mobility pattern from the application server. And when it comes to the radio, high coverage and so on, this gets repetitive. I just wanted to show you what do the operators take into account when they decide which network slices they will deploy and how many of them. And it's all really business driven, with the exception of these legal matters. And having said this, I hope I have prepared us for talking about the network slicing foldout tomorrow. So I will return to the different things that were mentioned yesterday and today, and I will try to make one comprehensive picture about network slicing. By the way, don't get me wrong, there is a 2 days long course about network slicing. This is a huge topic. I will channel as much information as I can, but if you have other questions, you can ask them also after the course or during the course. Otherwise, it's time to finish, obviously. So same rules as previously. 9 o'clock tomorrow, we start with this foldout. Anybody has questions or comments, I will be here for a little bit longer to listen for them. Otherwise, see you tomorrow morning.